Okay, welcome back to another AP Calc session here. Just a reminder that our exam is May 12th, so that is 1 week and 1 day away, and it's at 2 p.m. next Tuesday. So below I'm going to post some important information in the descriptions. It's things that you should either look at beforehand or print out in preparation for the exam next week. And I'll talk more about it as we go on in the week as well. Okay, on to 2016 stuff. So here we had 3 questions I wanted us to look at. This first one, yet again, they give us some graph of f, but when you notice in the description that they have some g function describing the antiderivative of f. This is that continual indicator that the derivative of g equals f of x. For this question, it looked like they didn't have their scoring rubric down great, because just saying this anywhere at any point in time gets you a point, that the derivative of g of x equals f of x. So that's a nice 1-pointer for them to throw on there. Does g have a relative minimum, max, or neither at x equals 10? Well, let's look at what's going on here. So we really know this is like the derivative there. And so we're thinking at 10, since it's a derivative, it's decreasing here. It's below, so it's going down. It's still going down. It hits 0, but it continues to go down. Since there is no change from positive to negative, that means it's not going to be a relative minimum or maximum, since this is really the derivative graph. So for A, we can say, since f doesn't change from positive to negative or negative to positive, neither. That's the thought here. And I think that's 1 point there as well for making that statement. Okay, on to question 2. Does the graph of f or g have a point of inflection at x equals 4? So remember, points of inflection, that's the second derivative. So since this is really the first one, we want to know, will it have one here at 4, a second derivative? Well, let's see what's going on here. To the left, it is going up, and it is going down after that point 4. So remember that second derivative there. So f prime of x would equal 0 at 4. Or it would change from positive to negative. It doesn't actually equal 0 because they're not smooth slopes. So the better thing is that it does change from positive to negative slopes. So for B, f changes from a positive slope to a negative slope at x equals 4. So this is an inflection point. And just to be safe, you need to say something like something about the second derivative here. So f prime equals g double prime, I think is what they're going to be looking for. And it's just 1 point there. C, find the absolute minimum and absolute maximum value of g. So we're really going to have to kind of be using this expression here, and we can kind of plug it off along the way. We can make some chart, the x value, and then what the g of x value is. And I think what's going to be really useful here is knowing that since this is an integral, we're looking for the area under the curve. So let's find out how big each of these areas actually is underneath the curve. So if we start with this one, it's just a nice little triangle here. Distance of 2, distance of 4, half base times height. That's getting us a 4. 8, because it's just 2 of them up here. Another 8, another 8, another 4. Things to keep in mind and that are important is where these different numbers are located, whether it's above or below the x-axis here. So since 2 is our starting point, we want to know where things are shifting from like above to below, because those are possible inflection points. So 6 is going to be one that we're concerned with. 10 is not, because although it hits 0, it does not actually change from below the x-axis to above it. And then we have to look at 12 since it's an endpoint. So we look at 6 because it changes f from positive to negative here. And 12 is an endpoint. And so by that same logic, since we had to look at 12, we also have to look at negative 4, because that's also an endpoint. So let's put that negative 4 in here, but I want a different color. And then where else does it change from positive to negative between here? It's just negative 2. So yeah, let's put negative 4. And then negative 2, but this one is because it goes from negative to positive. And this is going to help us find out our different areas. Imagine if you put 2 into the actual integral. It's the area from 2 to 2. There's no change there. So that's kind of our neutral starting point. Then we go up to 6. That means it gets 8 larger. Then we go along, since it's under the curve. All of a sudden, if we were trying to find 12, we have this initial 8, but then we'd be subtracting the other 8 and subtracting the 4, which would mean this one is a negative 4. Okay, let's look at this negative 2. And what's going to be important here is to think of the actual integrand setup here. Notice we're going from 2 to negative 2, which is kind of backwards of how we would think of it. So to properly look at this, you need a negative to kind of come out front. We know the area from negative 2 to 2 is 8. So this is, in fact, going to be a negative 8. We're going to have that same kind of logic follow through here, even though it's below the axis, since the integral that we would set up would be 2 to negative 4. We would kind of have to flip everything here. So it'd be negative the area from negative 4 to 2. Is that still on camera? Nope. So we need the negative of this area, which is a negative 4 and a positive 8, leaving us with a negative 4 here. And those are all the possible outcomes. Now they want us to find what again in this question? The absolute minimum. So what's the smallest number here? That's our absolute min, is negative 8. And the maximum is going to be at here. And I think that's pretty much it. They do want you to write these kind of things out, why you're looking at 6 or negative 2, 12, and negative 4. Those are important, but then making your claims are good. Last one. Between negative 4 and 12, find all the intervals where it is below 0. Since we just made this little chart here, that's going to make life actually a lot easier to find this. Where is the area below, or less than or equal to 0, so even 0 is included. So we know it starts off at 0, and let's think of going up. It goes up 8, goes down 8, it's back to 0, and it's negative here. So it's definitely from negative 10, not 112. Ugh, positive, what am I doing here? Let's just reset this whole thing. 10 to 12 is going to work. It's going to be negative there from 10 to 12. Right, I think it's 0, up 8, down 8, back to 0, and then negatives all the way here. Now we start at 0, but remember, when working backwards, this becomes negative. So it's negative for this whole section, and it's still negative over here. So we're also negative from negative 4 to 2, and then I think you just have to combo those, And so you can say this works out. And I think they give you a point per interval here is what they're looking at. Okay. Hopefully we're getting a decent feel at this style of question. They use it literally every single year. It's going to be there. My guess is it's still going to be there with this kind of year going on. Okay. Differential equation. I couldn't remember if we did this one or not. So if we did, we're doing it again. They give us this equation and they want us to sketch out some of these points here. Notice they have 1 blocked off because if you put 1 in here, we get 0 in the denominator. That's no good. So let's start testing out some points here. So when y is 0, the whole thing's 0. So the slope will be 0 there, so we can just draw 2 lines across. Going up 1, when y is 1, we know the numerator is 1. So now we got to just work on the x values. When x is 0 here, this is going to have a slope of -1. When it's 2, it's going to have a slope of +1. And then finally, when y is 2, we have 4 as the numerator, negative here, so even more slanted down, and then it's going to be the other way here, slanted up. Point breakdown is 1 point for the 0 slopes, so these get you 1 point. Non-zero slopes get you a point as well. Okay. They want the particular solution is just some y equals, and they want us to find the tangent line, and then use that to approximate this. So we've done a couple of these. So we want the tangent line first of all. So to get a tangent line, we need a point and a slope. They gave us the point here. The point is 2, 3. Now we need to find the slope here. So take your slope that's given to you, your dy dx, and evaluate it at 2, 3. So it's 9, 9. Y minus 3 equals 9. X minus 2. And now we have our tangent line, and let's just evaluate at 2.1. X equals y minus 3 equals 9 times 0.1. And then we're going to add 3 over. So that gets us y equals 3.9. Okay. Looking pretty good here. And this is worth 2 more points. So we're already up to 4 points and not too much time on these questions because we hopefully are starting to get the feel for how they go and how they work. And then C, very classically, find the particular solution to this differential equation. So that means, given this slope here, we need to separate variables and then solve. Variables separated, that's worth a point. So 1 point for just getting here. Antiderivatives. So the 1 over y squared becomes a negative 1 over y. The 1 over x minus 1 is going to become a natural log. And we can just tack on that plus c here. 1 point for each correct antiderivative. So already up to 3 out of the 5 points on this portion, and we haven't done too much. Now let's find out what that initial c is, given the initial condition 2, 3. So putting that in here, negative 1/3. That just becomes ln of 1. We have c equals negative 1/3. That is another point for us. And now we just need to do some algebra and some manipulation to solve here. We can negate everything. So we have 1/3 minus ln of. And if you think of this as some giant fraction here, we can kind of do some cross multiplication, reciprocal actions, however you want to think of it. and we should end up here, right? So if you think of just reciprocals, you can take these and do the inverse on both sides, and that's what we're getting here. You cross multiply and divide, whatever your brain wants to do. Either way, that gets us our last one here. Great. Flying through these questions. Really love these ones. It's the same exact thing every single time when you see them. And we're on to last one here. And here's one of the one-off style of questions. It's a little different than other years, but once you kind of get the grip of what they're trying to talk about in this question, it's going okay. Giant chart with a whole bunch of different derivatives in there. They say there are continuous second derivatives in the table above. And the first thing is they give you an f of g of x function defined as k. Whenever you're going to see something like this, just looking at this bit is looking just like some chain rule action. And if you look here, it's like, ooh, that looks like maybe we have some quotient rule going on. This style of free response is just testing, do you know chain rule, quotient rule, product rule, whatever they happen to be throwing at you. So the first bit is, in fact, looking at some chain rule knowledge. And they want a equation for the tangent line at x equals 3. Well, we need 2 points if we need a tangent line. We need a point, which they give us half a point. They give us it at 3. So we probably need to find out what the y-coordinate would be here. So let's put in 3. And the first thing that pops up is we need to know what g of 3 is. So that's where we go to our chart. X is 3. It's g. So this is now f of 6. So find our 6, find our f, 4. We've got our point. It's 3, 4. Now we also need to find out the slope. So to find the slope, we need to take the derivative here, which is just straight up the definition of our chain rule. Right, derivative of the f, leave it inside, derivative of the inside, little like hurricane rule going on there. Now let's evaluate here at 3. Okay, g prime of 3 is the first thing we can look at. So 3, the prime there is 2, and g of 3 is 6. So we have f prime of 6 times 2. F prime of 6, 5 times 2 is 10. So we have our point and we have our slope. So the equation would be y minus 4 equals 10, x minus 3. They are giving out 2 points for this correct 10 and then 1 point for the tangent line. So they're not giving out any points for finding out this point, but you do need it to get this tangent line. I just said something and wrote it different. You get 2 points for getting 10 there, the slope. Next bit, they give you a division and say find the derivative at 1. This is straight up quotient rule. And they kind of flip-flop the order, so you can't just say fig and gif right away here, because normally it's the derivative of the top. So our fig and gif are kind of flip-flopped here. And I think it should look something like this. Now we have to evaluate at 1. G prime of 1, f of 1, minus f prime of 1, g of 1, all over f of 1 squared. Okay, g prime of 1, so we're just sticking in the 1 column here. That's 8 times f of 1, it's negative 6, minus f prime of 1 is 3, and then g of 1 is 2, all over f of 1 squared. So that's negative 6 squared. Yet again, you can't leave your answers like this. They want it in like the smallest form possible. So 8 times negative 6, that's getting us